welcome back to Automation Days Asia 2022. My name is Jeremy, and I'll be the host for this session. So, just to share with all of you to keep the session more interesting and also engaging, please feel free to use all of the available features on the platform, especially the one with the question mark, to ask as many questions as you want, because we will be allocating some time at the end of the sharing session for Dr. Ernie to answer your questions. Okay? So, without further delay, let me introduce our speaker for this session, Dr. Ernie Teo. Dr. Ernie is the CTO of Dedoco and he leads the research and development of its technology applications. Dr. Ernie has over a decade of experience in economics and technology research. Prior to Dedoco, he was a research scientist at the IBM Center for Blockchain Innovation and was involved in blockchain projects covering provenance, finance, transport, and logistics. He is also the vice chairman of the Blockchain Association Singapore, giving talks in universities and conferences. So, for this session, Dr. Ernie will share how we can leverage blockchain technology in document management and security. So, whenever you are ready, Dr. Ernie, the floor is yours.
Thank you. Hi, everyone. I'm Ernie. Right. So today I'm here to tell you more about what's blockchain technology, and of course, the theme of this conference being automation. Also, how you can actually incorporate it into your automated processes. Right. So I'm from Dedoco, and Dedoco is a document process management application that's built on blockchain. Right. And follow us or find out more about us if you're interested in what we do. But today my focus will mostly be on what blockchain technology is and what it will mean for your business. Right. So to start off, I guess I need to start with a bit of fundamentals, and that is when blockchain was created and how it was founded. And that was actually in the year 2008, and it was introduced in a paper called Bitcoin, a peer-to-peer electronic cash system. So it is the Bitcoin white paper that's written by this guy called Satoshi Nakamoto. Right. To today, the identity of Satoshi Nakamoto is actually unknown. So we don't really know if this person really exists. But he did publish this paper. And in this paper, the technology that is used to create this peer-to-peer cash system that's Bitcoin is described. And part of that technology involves blockchain. Right now, to understand blockchain, we first need to understand what was Bitcoin's aim when it was created. And the aim is actually to disintermediate traditional digital money. Right? Because traditional digital money relies on centralized intermediaries like banks. And these intermediaries can decide which transaction goes through and which to freeze. And banks will need to take security measures and handle disputes, and this makes it very costly, and therefore banks have to charge you fees, right? With Bitcoin, the aim is to create trust by using incentives, probability, and computation. So by using digital trust that's created by these three elements, we don't need a centralized intermediary like a bank. It allows transactions costs to be actually cut by removing these intermediaries while making it impractical to reverse a transaction. And this impracticability of the transaction reversal comes from the blockchain part of things. So Bitcoin works using three basic fundamentals. The first one is it is a distributed network. So there's multiple parties in this network that is helping to validate the transactions as well as record the transactions into their own servers, right? So the network is run by a group of nodes. Anyone who wants to run a Bitcoin node can run a Bitcoin node. You can download software easily from the internet to be running a Bitcoin node as well. And anyone who runs a node on the network will own a copy of the ledger. So you get the entire transaction history of all Bitcoin transactions since the very beginning in 2008. It is also designed in such a way where no one individual can add incorrect information to the ledger or change it independently. So all the participants in the blockchain, right? A single person will not be able to go back in history and change something, right? You need a group agreement to actually be able to do that, and you need a group agreement or consensus to validate transactions that are also being added to the ledger, right? In a lot of articles that you read, you also hear that blockchain is usually append only. So you can add new transactions, but you cannot delete or change old transactions. Now, to achieve that, we require consensus, and the kind of consensus that is being used in Bitcoin is what's called proof of work or Bitcoin mining, and that is used to ensure that incentives are aligned and we reward the miners, right? So, what is a consensus? Is actually a set of rules or methods that are needed for the nodes on the network to agree on the transactions to be added to the ledger. This needs to be easy and efficient to validate these transactions as well. So Bitcoin mining is what's used as the set of rules in Bitcoin's case. If you're interested, you can go online and read more about that as well and how it works. Now, fundamentally, the most important feature is actually the use of blockchain, right? And blockchain uses cryptography. So cryptography is an area of mathematics, right, that deals with encryption, etc., to ensure that transactions are trusted and easy to validate. Now, to kind of understand how blockchain works as well, we need to actually also talk about what is a hash. So a hash function is a cryptography function. It actually takes data of an arbitrary size. So your Word document, your PowerPoint file, any kind of file, any type of data, right? And it will map it to a usually smaller fixed size arbitrary string. So I have a 10-page Word document. I convert it into a hash. I run it through a hash function. It will become a fixed size string of say, 200 characters or something. Right, so a hash functions like a digital thumbprint of a file. And a cryptographic hash function will have these certain properties. The same input, so if I have the same Word document, I haven't changed it, it's exactly the same. It will always give me the same output. It will always give me the same hash. Now, this hash is very quick to compute, right? It can usually be done within seconds. No matter what is the size of the input file, you can easily compute the hash. Now, a very important feature is that you cannot reverse engineer the input without brute force. So if I have a hash, I will not be able to convert it back into the original input, right? Without trying all the possible iterations in the world, right? So if I have a Word document, it will be very, very hard to reverse engineer, right? And almost impossible, right? So, and a small change in the input will change the output a lot. So I will not be able to tell by the output what has changed, right? If I change one letter in the Word document, it will change the output totally. And two inputs cannot generate the same output. So, and a change in hash means a file has been changed or tampered with, right? So with the very important characteristics, and all these characteristics and properties make a hash a very good method to ensure that we have a record of the document without having to store the entire document, right? And if the document gets changed and we calculate the hash again, we will know that the document has been changed, right? Or the file has been changed, right? So hashing is used a lot in blockchain. In fact, why is a blockchain called a blockchain? It's basically made up of blocks of transactions that are chained together with hashes, right? So it's a sequence of blocks that hold the complete record of transactions. Each block is hashed, and the hash is made the header of the next block, so thus creating a chain of blocks. So I have different transactions in my block, right? And then I hash all the data together to create hash number one, for example, if you see on the left hand side. Then I make hash number one the header of block number one, right? And then hash two composed of both hash one plus transaction three, right? Then I create hash two. Then I make hash two the header of block two, right? And then hash three is composed of hash two plus transaction four plus transaction five, and so on and so forth. So now if I'm at block number three and I have hash four already, and I try to change transaction three in block one, what will happen is we will get these broken hashes, right? Any just one tampered transaction will break all subsequent blocks, right? If I tamper with transaction three, then hash two will not be hash two anymore. It will be hash two prime, right? And therefore, I will be able to detect exactly where something got tampered with, and it will break all the hashes that follows. So it's a very important aspect of the blockchain, right? Because of this characteristic, blockchain is very tamper-proof, right? If someone tries to tamper and change any information, it will be detected very quickly. Now, all nodes of the blockchain, of the network, will hold a copy of the blockchain, and it is what we call a replicated database. So that means not only me as a server running on the blockchain has a copy, every server on the blockchain has a copy, right? So if all of us have a copy, then if I try to change my own copy, the rest will know that mine is different from theirs, right? So no one node can change its own copy of the blockchain. Bitcoin is designed in a way where transactions are grouped in 10-minute blocks, and Bitcoin mining is used to actually incentivize the nodes to participate because they can win a mining reward. Now, there are different kind of blockchain technologies available now, more than 10 years after the launch of the Bitcoin white paper. And there are now blockchains that are much faster as well, that actually clear transactions within seconds instead of 10 minutes. Now that we know briefly what is blockchain and how it works, let's next talk about what are businesses' interests in blockchain. So in 2014, it was the year where the Bitcoin price reached $1,000, right? And it got a lot of attention. How can something that's totally digital, is not used for anything, go from $0 pricing to $1,000 pricing, right? So it got a lot of banks interested in trying to understand what is the Bitcoin technology about. And so banks and other enterprises started to look at this in 2014. They started to look at Bitcoin and subsequently at blockchain technology as well. So these enterprises were interested to apply blockchain into their business process. And one of the key things that they see as very useful for them is the idea that you cannot, it's very easy to detect fraud, and you cannot easily double spend something. And that was what kind of inspired the first application of blockchain for business, which is on trade finance. So this was done together by Standard Chartered Bank as well as DBS Bank and the Infocom Development Authority of Singapore in December 2015. And that was on the double spending of letters of credits in the trade finance space. Now, of course, since 2014, we had, close to 8 years already. Different businesses has looked at blockchain in different ways and explored it in different ways. Now, what kind of features do these businesses want, and what do they not want? Well, they definitely like the idea of the trust within an ecosystem. So a group of different stakeholders can come together and use one blockchain. They will be able to share the same ledger and therefore share the same one source of truth. And they will be able to enjoy the benefits of the immutable audit trail that blockchain gives them. And therefore, everyone on the same network can trust the information and the database that is stored there. Second important feature is automation, right? I'm sure everyone may have heard about smart contracts before, right? Of course, smart contracts is not a new concept, But blockchain really revived the idea of smart contracts because of the fact that blockchain generally is transparent and trusted, and therefore you can run smart contracts on them, and different counterparties would be able to trust these smart contracts, right? You'll then be able to automate via smart contracts, and you'll be able to automate workflows, and that's what businesses want. Businesses also want to try to reduce the amount of friction in their systems, right? To disintermediate, to reduce the number of middlemen and friction and human involvement. And again, blockchain can come in to alleviate that for any business process. Now, however, businesses, when they look at blockchain and they look at the Bitcoin technology, for example, one thing that they decided, is not for them is things like full transparency and anonymity, right? They don't really want that for their blockchain network. They prefer privacy, right? They prefer the ability to not fully disclose all information to all nodes on the blockchain, right? They also want permission, meaning they don't want their blockchain to be accessible entirely to the public. For Bitcoin network, anyone, anywhere in the world can join the Bitcoin network. And businesses don't want that. They want some permissioning. They want that only designated people or designated companies to access their blockchain network. So since public blockchains cannot satisfy the last two requirements, it gave rise to another set of technologies called enterprise blockchain technology or permission blockchain technology. Now, if we compare the two technologies, the public blockchain technology, which is also known as permissionless. Why permissionless? Because no one requires permission to join a public blockchain, right? So anyone can join, whereas in the enterprise blockchain, only allowed parties can join. Now, all transactions are viewable by everyone on the public blockchain network as well. And in the permission network, transactions can be selectively shared with relevant parties. In the public blockchain, it is hard to identify users. People can try to be as anonymous as they want, right? Whereas in the enterprise blockchain space, all users are identified. Now, since all users cannot be trusted in a public blockchain, it is also known as trustless, right? A trustless network needs a very strong consensus algorithm, right? So Bitcoin mining or similar consensus is required to verify transactions. So examples of such kind of networks are Bitcoin and Ethereum. Now, on the other hand, with enterprise blockchain networks, since all users are trusted, right, all the nodes are known, selective endorsement is sufficient to verify transactions. And this applies to most business use cases. Some examples of technologies that support this is Hyperledger Fabric, Hyperledger Besu, and R3 Corda. But over the last 6 to 8 years, we actually see also a convergence of public and enterprise blockchains. Public blockchains are highly secure, transparent, and immutable. They are highly secure because they are very large. The Bitcoin network, for example, is made out of 10 to 100,000 number of nodes, right? But public blockchain networks are prone to performance issues and have problems scaling. And they are not designed for business use cases where more privacy and identity is required. Enterprise blockchains, on the other hand, are criticized as not being as centralized and secure. Participants of the enterprise blockchains are usually competitors, so they don't trust each other. And permission chains are more like intranets, and public blockchain more like the internet. So what kind of technology do you want to choose for your business use case? So the choice of technology really depends on your use case. There is a trend of now using public blockchains as a base to provide immutability and security of transactions. So the technologies that are being used are things like tethering or layer 2 chains. Now, what really makes a good blockchain use case for your business? Number one, there needs to be a real problem to be solved that is currently very difficult to solve with non-blockchain technology. you can benefit from these blockchain features of transparency, trust, security, immutability, disintermediation, and smart contracts. And thirdly, you must have an identifiable network or ecosystem, making out of your participants, the assets that are being stored on the blockchain. This could be, property, could be documents, it could be all sorts of different assets, and the kind of transactions that govern how these assets can be moved or created or transferred. So when using blockchain for your business, it's important to consider your these points, right? So first of all, you need to understand your pain points that you're trying to solve as an organization or as an industry group, and to actually be able to break down what are the problems that you're facing that you think blockchain can solve. And therefore, after you determine your pain points, you need to think about whether blockchain is the right solution to resolve these issues that you're currently facing, right? You need to consider all aspects, right? What is your technology that you want to use? What's your existing technology that you need to integrate with? What are the people involved? What are the kind of policies that need to be put in place? What are the business processes? And also a very important aspect, the user experience, right? Because in the business, not every stakeholder within the business, like your administrative staff, for example, would want to directly deal with blockchain technology, right? So the user experience is very important. How it works with the existing flow, how it works with the existing system is very important. Of course, blockchain itself has a very interesting potential because of its unique characteristics. There's an interesting potential to actually try to solve your existing problems in a whole new way, or to reimagine your current processes to solve it in a different way, right? So that can potentially be kind of a breakthrough, right? If you really get into the blockchain mindset and to think about how to kind of improve your business. Right. So what are the kind of blockchain use cases we see in the industry? Right. There are a few categories. So I just want to introduce three categories here today. Finance and insurance. Blockchain can be used in trade finance, like I mentioned earlier. It's also used a lot these days in cross-border settlements and payments between banks. Used in know your customer and anti-money laundering. It's also used in insurance for claims. You can also use blockchain for identity and certification, such as registration of assets like property or vehicles, registrations of citizen identities, creation of education certificates, or for medical records. So in Singapore, we have a project that actually does education certificates and medical records, which I'll show you later. Another big pillar for blockchain is supply chain and manufacturing, right? Things like global trade and food safety, where there's multiple stakeholders and multiple pieces of information being shared across the entire chain. That is when blockchain can have potential to actually benefit. Okay, so let's look at an example of trade finance, right? So We.Trade is a consortium that was founded by major banks in Europe, which connects buyers and sellers and their banks in a network to help simplify international trading. We.Trade used IBM blockchain to create a connected platform to simplify international trade, and went live in January 2019. So with We.Trade, SMEs can get access to capital. So one of the big problems for SMEs is that they lack capital and are exposed to a lot of counterparty risk in international trade. So and getting bank guarantees and financing were costly and manual and slow. So with the We.Trade system, you can create your purchase orders, etc., directly on the platform, and banks can offer you financing directly on the platform. So the We.Trade member banks bring buyers and sellers to the network after they KYC them, so it reduces concerns about risk. And once on the network, traders can manage their orders and get financing without worrying about legal, regulatory, and currency issues. They can also search the network to find new partners. So unfortunately, in this year, June 2022, Trade actually entered insolvency after the bank shareholders pulled the plug. So a lot of banks were stakeholders in Trade and licensees as well. So what happened there, right? I think from my own point of view, I think like such kind of consortiums are very hard to manage, right? Because everyone has a share. You see, all these banks, all these tech companies, they have a share in the ecosystem, right? And it's very hard to manage, and therefore the shareholders pulled funding, right? Because it's very hard to manage. Okay, another example for insurance is called Fizi. It's done by the AXA Group. So Fizi is a parametric insurance. It's 100% automated, and it's insurance against delayed flights. So Fizi uses flight statistics and smart contracts to check flights and automatically reimburse passengers if their flights are delayed. So this Fizi platform was built on Ethereum, and purchases were recorded on smart contracts and paid out also made in via smart contracts. So this is a flow of how things happen. You can buy your insurance online, make payment, and if your flight is delayed, you are automatically paid out into your bank account. So Fizi was discontinued in 2019. It was started in 2017. Some reasons are that it couldn't reach its commercial targets. There's not sufficient market appetite for blockchain-based consumer insurance product yet, and the right distribution channels don't yet exist for Fizi. But I think if Fizi is created today, the story may be quite different, right? Because the world is more accepting of cryptocurrencies and blockchain. So although not successful, Fizi is a very interesting use case for the industry, and it shows what can be done. So a third example I'd like to show you is for certifications. So OpenCerts was first piloted for issuing digital diplomas at Ngee Polytechnic in Singapore. It was rolled out in May 2019 to 18 educational institutions in Singapore, including major universities like NUS. So OpenCert is part of the Smart Nation Initiative of Singapore, and it utilizes what's known as the Open Attestation Standard. Open attestation was also being used during the COVID-19 period for test results and vaccination certificates. If you're interested to find out more, you can go to opencert.io. Right, and this is how generally OpenCert works. The school will issue the cert via a issuing application, and it calls the smart contracts in the blockchain. Right, and then this certificate is given to the student. The student can pass it to their future employers, who can verify these certificates through a web application that also queries the blockchain to verify the information. Okay, the last example I have is for supply chain, and that's related to Food Trust, which is a project originally created by Walmart and IBM. They came together in 2016 to solve a food safety challenge. And they started with two projects. One is about tracing the origin of mangoes sold in Walmart's US stores, and the other to trace pork that is sold in China stores. The result was Walmart was able to trace the origin of over 25 products from 5 different suppliers. So after having a successful pilot, Walmart then collaborated with IBM and others to set up IBM Food Trust, which involved prominent players in the food industry like Nestle and Unilever. Food Trust today boasts a very large network of users covering many different types of use cases. Now, so of all these examples, what are some of the lessons we learned? First of all, market readiness is very important, as we learned from AXA. Consortiums are not easy, as we learned from Trade. Public blockchains can also be used for enterprise applications. So examples are AXA's Fizi as well as OpenCerts, right? And good use cases will find traction, right? So such as Food Trust. After getting started a couple of years back, it now found infiltration within the industry. So there are many paths to Rome. Every business will have its own journey regarding blockchain implementation. So we at Dedoco actually offer flexible solutions to help you tap onto blockchain benefits, right? And the next wave and the next evolution for the internet or the World Wide Web is really about the Web3 revolution or the evolution. So Web3 or Web 3.0 is what will enable peer-to-peer interactions for the World Wide Web, and it aims to empower the end users, right? So, and it aims to do that through applications that allow the sharing of decentralized decentralized sharing of information as well as sharing of digital assets. So, for example, you can share you can bring your cryptocurrencies from one web application to another web application, and you can use it to buy different things, or buy NFTs, etc. But you can imagine Web3 also means that if we put your documents on blockchain, you can bring your documents from one company to another company, from one application to another application, and have those applications trust the document and be able to use it, right? So the new enablers, key enablers of this new paradigm is decentralization, smart contracts, as well as tokenized assets. So blockchain can enable Web3 for your business. So any company, when you're doing through your business deals, you deal with different documents like contracts, agreements, or documentation, right? And your documents go through several stages of approvals or acknowledgements, right? But the problem right now in today's systems is documents are generally not trusted between systems, right? So when a document flows out of your company systems and go to another company, usually manual data entry may be required, or some kind of trust checks or validation needs to be done. Now Web3 can potentially change this, right? At Dedoco, we have something called a non-fungible document process, where we use it to provide provenance of a document. It proves who's the issuer of the document, who are the approvers, who are the owners. It proves the originality, whether the document has been tampered with, if it has changed, what are the versions that it has gone through, right? And ultimately making it digitally trusted. And with the non-fungible document, we can allow for decentralized sharing of information and documents. You can bring your own documents to whatever application that you want to go to. You will enable businesses and individuals and bring change to the competitive landscape. So imagine if you can go and get um, a business loan by just logging into a lender's website and sharing documents with them. So instead of having to wait weeks or months for the due diligence process for your line of credit to be approved, with this kind of trusted documents, you may be able to get approval in seconds. Another important aspect of transitioning from Web 2 to Web 3 is to provide that bridge from Web 2 to Web 3, right? We need to be able to help you convert your outputs to Web 3, digest and trust Web 3 documents, as well as to connect to Web 3 tools. And with if you have API integrations, you can build your own standard business process to share within your ecosystems, and partners can take part in the business process, and there's no need to join blockchain networks. Right, so that brings me to the end of my presentation. If you are interested to find out more about how you can tap onto blockchain as a business, you can contact us and we'll be happy to chat.
Thank you so much, Dr. Ernie, for your insightful sharing session. I really like how you managed to explain blockchain technology in a simple but yet insightful manner, especially covering the concept of blockchain technology and applications as well. So we do have maybe around less than 10 minutes to cover some of the questions that I have here. Maybe what I will do is that I'll project the question, Dr. Ernie, then maybe you can help us to answer some of those questions.
Yep,
All
sure.
right, let me project the first question. Okay, so we have one question. My understanding is that blockchain is still maturing and used mostly in Bitcoin as a use case. So how does it relate to automation?
Mm. Oh, that is not really true, right? So if you've seen the examples that I shown you earlier, is used to track food supply chain, for example,
Mhm.
right? It basically tracks from farm to fork. What we mean by that is it goes through the entire kind of food processing process. So if you harvest mangoes from the farm, and then you you kind of transport it to a manufacturing plant, turn it into cans, right? The entire process is tracked so that you'll be able to trace where it comes from. So how this impacts automation, right? If you include smart contracts, so smart contracts are basically rules, right? That can manage digital assets. And your digital assets in this case could be your delivery orders,
Mhm.
could be your invoices, etc. Right? And when certain events happen, it can trigger the next event. So that's how blockchain can bring in automation, and there's automation across entities without and it builds in the trust across the multiple counterparties,
Mm,
right? So it actually like embeds the rules that says you can only trigger the process if certain conditions are met, right? So and it helps you perform your due diligence, and it automates the process as well.
yeah, I see. Thanks for explaining that, Dr. Ernie. Because I think most of us, when we hear about blockchain, definitely we will relate that to Bitcoin, right? Because that's how
Yep.
most of us hear about blockchain. Yeah.
Mm,
Then we have maybe another question. Let me see. Let me project this question. Okay, so blockchain was mainly started within the financial sector when it comes to business applications. Can you share how other companies in different industries today are using blockchain technology? I think maybe this question was asked before you share those use cases,
mm,
but I
mm,
do have one question over here as well because I did see that you showed a few industry are already using blockchain. I'm interested in manufacturing. So
mm,
based on your experience and your view, right, Ernie,
mm.
is manufacturing industry already adopting blockchain technology, or
Yep.
they are just starting, trying to explore what is
Mm.
blockchain technology?
Okay, so I think like certain more complex manufacturing processes can definitely benefit from blockchain, especially if there's a lot of different stakeholders involved. From what I know, there's a lot of companies that has been exploring using blockchain to do this for a while. Some examples could be like, for example, aircraft manufacturing, right, where
Mhm.
where the parts are very important, like the origin of the parts, and they don't want third party parts. They want the original, right, and they want to make sure that it's the original,
Mm,
right? So there's currently, if you go and look at the aircraft manufacturing process, they have like these huge sheets where people have to sign off every time that they do something.
yeah.
And basically, if we are able to digitize that, and we can actually then introduce automation as well, right? Because if someone like one of the kind of persons involved, like they install certain parts into the plane and they sign off and they acknowledge, right? That can trigger the next person to come in, right? You don't need to pass this piece of paper around. It goes back to some central party before they call up the next person and say, now it's your turn, come in and install this thing instead, right? So that can be a lot, but then it also an upgrade from the paper process, or because everything is digital, it's easy to track and trace. So if anything does go wrong, there's any faults with the plane, etc., it's very easy to identify what goes wrong, and where it has went wrong. And that's very important when it comes to insurance claims as well, right? Because who is the one that's really responsible, right? It's very important when someone is trying to investigate the claim.
Yep. Thank you
Mm.
so much for that, Dr. Ernie. Then we maybe can try to answer one more question. Let me project that question. Question from Pradeep. My understanding is that blockchains do to P2P networks what Facebook did to email or SMS. Am I right?
Mm, Well, okay, so what blockchain is doing to P2P network is it is kind of decentralizing it. It's enabling true peer-to-peer,
Mm,
right? So it's allowing, like, okay, if we go back to cryptocurrency, it allows me to transfer someone else tokens or cryptocurrencies or bitcoins without going through any central party, right? It doesn't require me to. So if for example nowadays, if I make a money transfer to you via a bank app, right, I go through the bank system needs to kind of acknowledge and approve it for it to happen,
yep.
right? But in the Bitcoin system, nobody is responsible to kind of acknowledge that, because the whole network is designed in such a way that everyone will help to validate it and help and then acknowledge this transfer, right? So it's true peer-to-peer because the token goes into your wallet. Whereas if you're doing like digital money bank transfer again, right? Actually, my money doesn't go into your wallet, right? It actually is like my bank's money. Like my bank will tell your bank that it owes them
Yeah,
$10,
yeah.
right? So it's just appearing on the book. So it's not true peer-to-peer,
Mm,
right? So that's what blockchains aim to do true peer-to-peer transfer of digital assets. So even like transferring of documents. So imagine if we have a document that says that I am the owner of this piece of property, right? And I want to sell you this piece of property, right? So right now, to do that, we have to go through a lot of legal documents. We have to go to a lot of different government agencies to get it approved and acknowledged, right?
mhm,
So imagine if we can build in smart contracts that help to manage these rules, right? And then you try to initiate a transfer. If all the rules pass and everything, the smart contract will do its checks, right? And once everything is okay, it will transfer directly the property into your wallet, and you own the property, right? You have proof that you own the property,
mhm,
and it will disappear from my wallet, and can never make a claim on it anymore,
mhm.
right? So that is also another example of a peer-to-peer transfer.
Okay, okay. All right. So with that, Dr. Ernie, unfortunately, we might need to end the session because we have a few more minutes left. So I'd like to thank you so much for taking your time for joining us today, and I hope to see you
Yep.
again soon. So for the rest of you, I do see that we have a few more unanswered questions. So feel free to reach out to Dr. Ernie from Dedoco to ask any questions that you'd like to ask. Okay.
Right.
So let me share my screen. Um, 1 second. So we do have upcoming sessions coming from three speakers in track 1, 2, and 3. So for track 1, if you're interested, you can join. The topic will be about hyper automation in healthcare, the good, the bad, and the future. For track 2, will be about process mining, application of data science, and for track 3, we'll be talking about modernize your warehouse. Okay, so I'll see you in the next session. Once again, thank you so much, Dr. Ernie.
No
Take
problem.
care. Bye bye.